Simple harmonic motion. What is a SHM? If you define the simple harmonic motion means when object is to and fro motion with respect to the one origin or mean position, acceleration is directly proportional to displacement but in opposite direction. Means once again I am repeating this one. If I am taking one string, it is one metallic bob is connected, and here it is one end it is fixed and metallic bob, mass of the metallic bob it is m. Here length of the string it is suspension point to center of the metallic bob, we can call it is the length of the pendulum. Suspension point to center of the bob, we can call it is the length of the pendulum. When it is in to and fro motion, with respect to origin, acceleration is directly proportional to displacement but in opposite direction. Here while it is moving away from the mean position, displacement is increasing but acceleration of the block it is always towards the mean position. See, when this bob it is moving away from this one, acceleration is towards the mean position. So that's why only acceleration and displacement both are in opposite direction. Now how we can derive this equation? We know it is time period is equal to 2 pi under root of L by G. That we are deriving now. So simple pendulum derivation. So this is simple pendulum. Now it is oscillating. When it is oscillating, just I am taking one small angle. Now the position of the pendulum it is here. Angular displacement is theta. At that moment, tensional force is acting upward direction. Means tensional force is always away from the object. Now weight of the bob is acting downward direction. This weight is resolved into the two components. One is horizontal component. Is mg cos theta, and vertical component is, this is direction, vertical component is mg sin theta. And length of the pendulum it is nothing but earlier only I told you it is the L. Now what about this time period? What about tensional force and mg cos theta? Because it is going upward direction means you can write the equation T minus mg cos theta. Here T minus mg cos theta can be represented as the radial acceleration. It is the T minus mg cos theta can be representation is the radial acceleration, and mg sin theta can be represented as a tangential acceleration. T minus mg cos theta resultant can be represented as a radial acceleration. So mg sin theta is the radial tangential acceleration, and T minus mg cos theta can be represented as a radial acceleration. Both you have to remember. But here radial acceleration means tau is equal to torque can be experienced. Here mg cos theta is balanced. We can write as a equation it is mg sin theta is equal to mg sin theta. Tangential acceleration produces the torque. So that's why this is restoring torque. F is equal to minus mg sin theta I am writing. Restoring force F is equal to minus mg sin theta. Restoring force F is equal to minus mg sin theta, and torque is equal to, tau is equal to, you can write as a force into perpendicular distance. Now force is equal to what you can write, minus mg sin theta, and perpendicular distance is nothing but this is the perpendicular distance. Here along this direction mg sin theta is acting, L is nothing but a perpendicular distance. So I am writing it is L. And rotational torque, this is balanced by the rotational torque. Torque is equal, rotational torque is equal to what you can write, I alpha. Rotational torque is nothing but a I alpha. Then from this equation you can write I alpha is equal to minus mg theta into L I am writing. Because the angle is very small. Sin theta is nearly equal to theta. When angle is very small, sin theta is equal to, you can write as a theta. So this equation, sin theta I have written as a theta. Now alpha is equal to minus mg L divided by I into theta. Now in this one, alpha is the angular acceleration and theta is the angular displacement. Now just I want to compare this equation. A is equal to minus omega square y. What is A? Linear acceleration. What is y? Linear displacement. Linear acceleration, linear displacement. Angular acceleration, angular displacement. So instead of the omega, what it is there, just I am comparing these two equations. Here omega is equal to, I can write omega square is equal to mgl divided by I. What about I is equal to moment of inertia mr square. Here r is nothing but a L. I is equal to mr square. R is nothing but a L. So mass get cancelled. L square L get cancelled. You can write omega square is equal to G by L. Then omega is equal to under root of G by L. Then omega means 2 pi by T. Omega is equal to 2 pi by T under root of G by L. Then we need time period of the simple pendulum. Time period of the simple pendulum means T I am taking right hand side and remaining this one I am taking this side, left hand side. T is equal to, we can get 2 pi under root of L by G. Time period T is equal to 2 pi under root of L by G. Now frequency is equal to, what about frequency? Reciprocal of time period. Otherwise number of oscillations done in 1 second is called frequency. And we can write frequency is equal to 1 by time period. So time period, this one we can write as, if we substitute in this one, we can get 2 pi under root of G by L. Frequency equal to 1 by 2 pi into under root of G by L. This is the frequency and it is the time period. Now these applications we have to do it. These applications how we can do it means, I want to tell, for example, if the simple pendulum is placed inside the lift, if the simple pendulum is placed inside the lift is going upward direction. When lift is moving downward direction, what is the time period? If lift wire is disconnected also, what is the time period? That we have to calculate. We know first, before going to that one, what is the, when lift is going upward direction, what is the effective gravity we have to calculate to know, find out the time period. First, we know it is very well, that is in the laws of motion topic only. First, I am taking it is, this is lift, one person is standing, it is connected to the string, rope. Now tensional force is acting upward direction, weight of the object is acting downward direction. If lift is going upward direction, see the symbol it is mentioned, lift is going upward direction, that is accelerating, that meaning it is nothing but a acceleration. So when lift is moving upward direction, at that time what you can write the equation, time period, tensional force is greater than the weight of the object. Resultant force is equal to, because the object is going upward direction means upward force is greater than the downward force. So that's why I am writing resultant force is equal to, upward force is T and downward force is mg. Here resultant force, what you can write, ma. T minus mg, tensional force minus weight of the object. T is equal to ma plus mg. Here T is nothing but we can represent as a operant weight. T is represented as a operant weight. So mg dash is equal to, if I take common m, this equation you can write as a g plus a. Both side mm get cancelled. G dash is equal to, what you can write, it is formula g plus a. G dash is equal to g plus a. When lift is going upward direction, your weight is appears to be increases, because weight is nothing but a mg. weight is nothing but a mg, but ma is addition to the mg, means some force is acting on that one. At that moment your operant weight appears to be increases. When person is standing inside the lift, the weight appears to be increases. When person is moving downward direction, the weight decreases, appears to be nothing but a decreases. Both cases you have to observe. So here we got it is, when lift is going upward direction, what we got it is, G dash is equal to G plus A. When lift is moving downward direction, what we can get, G dash is equal to G minus A. When lift is moving downward direction, G dash is equal to G minus A. For example, lift wire is disconnected. Lift wire it is disconnected. It is nothing but a freely falling body only. When lift wire is disconnected, it is freely falling body. Freely falling body means, what about acceleration is equal to, freely falling body means acceleration is equal to, we have to write as a gravity. So G dash is equal to, this is lift is going upward direction, this is lift is moving downward direction formula. So G dash is equal to G minus A. A is equal to what we have to write, G. So that is nothing but a 0. So when lift wire it is disconnected, it is nothing but a freely falling body. When object is freely falling body, your weight is equal to 0. Now this case I am applying into the simple pendulum. Okay, when lift is going upward direction, for example, simple pendulum it is placed here. Now lift is going upward direction. When lift is going upward direction, what is the time period formula? 2 pi under root of L by G dash. Here G dash is nothing but a 2 pi under root of L divided by G dash is equal to G plus A. This is the equation. When simple pendulum it is placed inside the lift is going upward direction, the formula it is time period is equal to 2 pi under root of L by G plus A. When lift is moving downward direction, 2 pi under root of L divided by G dash is equal to G minus A. 2 pi under root of L by G minus A. When lift wire is disconnected, means here this part it is 0. Time period will become infinito. When lift wire is disconnected, weight is 0, but time period it is nothing but a infinito. It will be takes place. And one more. For example, in truck, I am taking in the truck. See here, it is a one truck. One simple pendulum it is placed. Now the truck it is moving forward direction. It is accelerating forward direction. What about the, when lift is not lift, I taken the simple pendulum it is inside the truck. The truck it is moving forward direction, means it is accelerating forward direction. At that moment, what about the time period? What about the time period? So I am taking it is, when lift it is going forward direction means weight of the simple pendulum it is acting downward direction. Weight of the simple pendulum it is acting downward direction, and force it is along this direction, that is MA. Now these two are perpendicular to each other. Weight is acting here and force is acting along this direction because it is accelerating along this direction. Now resultant force, that is F. We have to apply here perpendicular. It is parallel axis theorem at this point of. Parallel axis theorem is equal, these two are, this is one force and this is one force. These two are perpendicular to each other. At that time, resultant force Fr is equal to what you can write under root of, what is parallel axis theorem formula, under root of P square plus Q square plus 2PQ cos theta. Here, what about angle between these two? It is the 90 degrees. So we can write only R is equal to under root of P square plus Q square. Okay, this one I am assuming as a P and this is nothing but a Q. Mg whole square plus Ma whole square. Resultant force This is mg dash I am writing under root of m square g square m square a square. M square if I take common, both side m get cancelled. G dash is equal to, we can get g square plus a square. Then substituting the formula, t is equal to 2 pi under root of L by g dash. So 2 pi under root of L divided by this one, whole again root g square plus a square. This is the time period equation. When simple pendulum it is placed inside the truck it is accelerating horizontally. At that moment time period is equal to 2 pi under root of L divided by under root of again g square plus a square. Now the truck it is moving on a curved path. At that time, what is the time period? For example, when it is object is on a curved path, truck it is moving on a curved path. It is taking turning like this. At that moment, the simple pendulum will be oscillate towards the center or away from the center. Any one of you. Obviously, it is away from the center. How it is means, it is nothing but a inertia of direction. When you are going by the car, if car it is taking right side means you may fall it is left hand side. That is nothing but a inertia of the direction. Same here, due to the inertia of the direction and centrifugal force, actually that we have to call here, it is the centrifugal force, a force which is acting towards the center, that is the centripetal force. A force which is acting away from the center, that is the centrifugal force. At that moment, the metallic bar will be moved away from the center. So centrifugal force is acting on the metallic bar. In this one, weight of the object is acting downward direction. Centrifugal force is acting towards the right hand side. Centrifugal force it is acting towards the right hand side. Okay, resultant force it is along this direction. This is the resultant force. I am writing centrifugal force. What is the centrifugal force equation? mv square divided by r. Centrifugal force is equation, it is the mv square divided by r. Okay, according to this one again, Fr is equal to under root of, you can write as mv square divided by r whole square plus mg whole square. Just now only we used it is the parallelogram equation. Parallelogram by equation, it is resultant is equal to under root of p square plus q square. This is p and this one it is the q, resultant force. Both are perpendicular to each other. Weight of the object is acting downward direction. Centrifugal force is acting towards the right side. So both are perpendicular to each other. Okay, resultant force I am writing as a mg dash, and m square if I take on that side, m will come outside, and here b to the power of b square whole square is there. So that's why b to the power of 4 r square, and here it is g square. Both side m get cancelled. G dash is equal to, we can write b to the power of 4 r square plus g square. What is the time period equation? T is equal to 2 pi under root of L by g dash, that is equal to 2 pi under root of g dash is nothing but m v to the power of 4 divided by r square plus g square. Then time period is equal to, we can write the equation. T is equal to 2 pi under root of L divided by under root of v to the power of 4 by r square plus g square. When simple pendulum it is in a truck, the truck it is taking a turning. When truck it is taking a turning, on the simple pendulum, weight of the object is acting downward direction. Centrifugal force is acting towards the center. Okay. For example, if the simple pendulum it is placed inside the water, if it is oscillating, how we can write? What is the time period? When simple pendulum it is oscillating inside the water, what is the time period means? We have to know it is what is the operant weight, loss of weight. For example, first I am writing loss of weight is equal to weight of the object in air minus, we are writing weight of the object in air minus weight of the object in liquid. We are writing first These two resultant is nothing but a loss of weight. Weight of the object in air minus weight of the object in water or liquid. For see, I am taking this is one simple pendulum. Weight of the object in air, it is WAR, and if it is placed inside the water, at that time weight of the object inside the liquid, it is WA. The loss of weight is equal to weight of the object in air minus weight of the object in liquid. Simply you can analyze like this. For example, one block, 10 kg block, in the air it is weight is nothing but 100 newtons. If I place inside the water, the weight will be decrease or increases? Automatically decreases. For example, now the weight it is 75. In water 75, in air 100. What is the loss of weight is equal to 100 minus 75 is equal to 25. So that only I am writing. Loss of weight is equal to weight of the object in air minus weight of the object in liquid. So weight is equal to, we know it is very clearly mg. It is in air. It is in air minus, this is in water or liquid. Mass is equal to what you can write? Density into volume. Mass is equal to density into volume. So I am writing density of the body and volume into G. Density of the body, volume. Mass is equal to density of the body into volume. Minus mass, it is density of the liquid into volume into G. See here, when object is placed inside the water, equal volume of the water will be displaced. That's why only this in the air volume, in the liquid volume, both we are taking as a same. You have to remember, weight of the object in air means I have written as the density of the body into volume. Weight of the object in water or liquid, if I am writing, I have written as the density of the liquid into volume. In this situation, I am taking common, it is loss of weight is equal to, I am writing mg dash. I am taking common, it is density of the body, volume into G. If I take common, what you can write? 1 minus Vg is same, but here density of the body is not there. No? Density of the liquid divided by density of the body. Density of the liquid divided by density of the body, and this rho b and v I am writing as a m. 1 minus rho l divided by rho b, that is equal to mg dash. Mm get cancelled. G dash is equal to G into 1 minus rho l divided by rho b. This equation we can substitute in the time period. T is equal to 2 pi under root of L divided by G dash means G into 1 minus rho L divided by rho B. When object is oscillating inside the liquid, what is the time period means? T is equal to 2 pi under root of L divided by 1 minus rho L divided by rho B into G. Object is, when pendulum it is placed at a certain height from the surface of the ground, what is the time period? At that moment the time can be, we can lose the time. So how it is? What is the equation? For example, when pendulum it is placed on the surface of the ground, when pendulum it is placed on a surface of the ground, at that time the equation we know it, T is equal to 2 pi under root of L by G. When pendulum it is placed on a ground at that moment. But when pendulum it is placed at certain height, when pendulum it is placed at on a certain height, at that moment what is the equation? T is equal to 2 pi under root of L divided by G into R by R plus H whole square. We know this equation. G dash is equal in the gravitation chapter. In a gravitation chapter, GH is equal to G R square divided by R plus H whole square. Gravity at certain height. If you calculate this one, you can get as a G into 1 minus 2H by R. Gravity at certain height. While you are going upward direction, gravity will be decreases. When you are going depth of the earth also, gravity will be decreases. So in both the cases, time also you can lose. That's why gravity at certain height, equation it is gr square divided by r plus h whole square. If you calculate this one, you can get this equation. So I am writing time period on the earth surface, t is equal to 2 pi under root of L by G. Time period on the at a certain height, time period at a certain height, t dash is equal to 2 pi under root of L by G into r plus h whole square. Now this is equation 1 and it is equation 2. Equation 2 divided by equation 1, if you solve it, t dash divided by t is equal to 2 pi under root of L by G. This one I am writing, this I am taking numerator, r plus h divided by r whole square, just I am writing whole divided by t is equal to 2 pi under root of L by G. See here, 2 pi under root of L by G, 2 pi under root of L by G get cancelled. What are the remaining here? Square and square root get cancelled. We can write r plus h divided by r. So t dash by t is equal to r plus h divided by r. This equation you can write as a r by r plus h by r, that is equal to 1 plus h by r. So here square and square root get cancelled, that's why r plus h by r get cancelled. So this one I am writing as a r by r and h by r. R by r is nothing but a 1. Now 1 I am taking this side. T dash minus t dash by t minus 1 is equal to h by r. So t dash minus LCM is the t. T dash minus t minus 1 is nothing but a t dash minus t divided by t, that is equal to h by r. Here this is loss delta t I am writing. Delta t is nothing but a loss of time divided by t, that is equal to h by r. So delta t, loss of time per day, loss of time per day, delta t is equal to h divided by r into capital T. What is the height? H is nothing but a height. What is the capital radius of the earth? What is the capital T per day? How many seconds? What is the how many seconds per day? 86,400 seconds. So delta T is equal to, we can get h by r into 86,400 second. It is the time loss when the simple pendulum is taken at certain height from the ground. Loss of time is equal to h by r into 86,400 seconds. Next one, if the object is taken at a certain depth from the surface of the earth, pendulum it is placed at certain depth from the surface of the ground. This is simple pendulum. It is placed at a depth d from the surface of the ground. We know very clearly time period on the surface of the ground. On the surface of the ground, 2 pi under root of L by G. And when time period, what is the time period? When object is placed, simple pendulum it is placed at a depth d. At a depth d, 2 pi under root of L divided by G into 1 minus d by r. Actual formula it is, in the gravitation only we can get, when object is going depth of the earth, gravity at a depth, particular depth is nothing but a GD is equal to G into 1 minus d by r. That GD value is substituted here. Again, this is equation 1 and this is equation 2. Equation 2 divided by equation 1, if you taken t dash divided by t, that is equal to 2 pi under root of L by G and 1 divided by that this only I am writing, okay, 1 minus d by r whole divided by t is equal to 2 pi under root of L by G. Both get cancelled. What is the remaining here? Under root of 1 divided by 1 minus d by r, we got it. See here, t dash by t is equal to 2 pi get cancelled, L by G get cancelled. Here remaining it is 1 minus d by r. 1 divided by 1 minus d by r. Okay. T dash minus t is equal to, I am writing this equation is 1 divided by r minus d divided by r to the power of 1 by 2. Otherwise, we can write like this also. We can write like this: 1 divided by 1 minus d by r whole to the power of 1 by 2. Just I am writing this equation. It is square root I am writing as a to the power of 1 by 2. Square root I have written as a to the power of 1 by 2. I take it to the numerator. If I take the numerator, 1 minus d by r to the power of minus 1 by 2. The power will become as a minus. If I apply the binomial theorem means if I apply this minus 1 by 2 in our physics, every time you have to remember when you are applying the binomial theorem, this minus 1 by 2 will become here. No need of the everything formula that is. Just we can apply directly. Minus 1 by 2. Minus into minus plus. 1 by 2 I am writing d by r. Then t dash by t. Again 1 I am taking this side. T dash by t minus 1 is equal. What are the remaining here? 1 by 2 d by r. Again t dash minus LCM is the t. Here LCM is t. That is equal to 1 by 2 d by r. T dash minus t is nothing but a delta t. That is loss of time. That is equal to 1 by 2 d by r. Then delta t is equal to loss of time per day. Delta t is equal to 1 by 2 d by r. This t I am taking this side. 86,400 second. 86,400 t value I have written. This t value I have written. Delta t is same. This t if I taken directly t value 86,400 second. So when simple pendulum is taken at certain height from the surface of the ground, and when you taken at a depth from the surface of the ground, it is both the cases we can observe the loss of time period per day. It is nothing but there it is h by r into, that is nothing but h by r when it is taken at a certain height delta t, but when you take it at depth 1 by 2 into d by r into 86,400 second. Okay. Consider two simple pendulum of different length. Length of longer length simple pendulum it is LL, shorter pendulum length it is LS, and time period for the longer pendulum it is TL, shorter pendulum it is the TS. For your understanding, I draw the diagrams. One it is longer pendulum and one more it is the shorter pendulum. So longer pendulum length it is LL, shorter pendulum it is nothing but a LS. For longer pendulum time period is TL and shorter pendulum it is time period is TS. Now both are started from the same phase. These two pendulums are started oscillating with the same phase. After t time interval, both are again coming into the same phase, but the number of oscillations are done by the longer pendulum it is n and shorter pendulum it is n plus 1. Remember, see the problem once again. The longer pendulum, both are started oscillating with the same phase only, but after t time interval, again both are coming into the same phase, but the oscillations are different. The oscillations done by the longer pendulum it is n and oscillations done by the shorter pendulum it is n plus 1. So what is the number of oscillations we have to calculate? For your understanding, again I am repeating this one. Length of the longer pendulum it is LL, length of the shorter pendulum it is LS. Time period for the longer pendulum it is TL, shorter pendulum time period is TS. Both are started oscillating with the same phase. After t time interval, while it is oscillating, both are oscillating like this. But after t time interval, both are coming into the same phase. Both are coming into the same phase. So how many oscillations done by the shorter pendulum and longer pendulum, that we have to calculate. Means for the time it is, for both the cases, time it is the same only. I am writing it is number of oscillations done by the longer pendulum, it is n into TL. Number of oscillations done by the longer pendulum, it is the TL. And number of oscillations done by the shorter pendulum, it is n plus 1, that is TS. See here they given shorter pendulum number of oscillations is n plus 1 in T time interval. For your understanding again I am telling, because it is to understand only, it is somewhat difficult. In a T time interval, longer pendulum oscillations are n. In T time interval, shorter pendulum oscillations are n plus 1. So time interval it is same, but oscillations are different. So that's why T is equal to n into TL and T is equal to n plus 1 into TS. Then multiply inside, n into TL is equal to n into TS plus TS. Then if you take the TS is n into TL minus TS is equal to n, I am writing. This is TS, this is also TS. Just n TS I taken left hand side, n if I take common, TL minus TS is equal to TS. Then n is equal to TS divided by TL minus TS. So number of oscillations done by the longer pendulum, number of oscillations done by the longer pendulum is equal to time period of the shorter pendulum divided by time period of the longer pendulum minus time period of the shorter pendulum. This is the number of oscillations done by the longer pendulum. For example, if you want to calculate number of oscillations done by the shorter pendulum means how much it is n plus 1. You can write how much you are getting answer, that is shorter pendulum time period. So number of oscillations done, one it is more. N oscillations done by the longer pendulum, n plus 1 oscillations done by the shorter pendulum. For example, 5 oscillations done by the longer pendulum means 6 oscillations done by the shorter pendulum. Okay. For example, if they given instead of the time period, length if they given, how we at that moment, how we can write this equation, we need it. Means time period equation T is equal to 2 pi under root of L by G. Time is directly proportional to root L. So where is the time period? You have to write as a length under root of L. Means this equation only I am writing, n is equal to TS is there. Time period is directly proportional to root L. Means time period, shorter pendulum length, it is nothing but a Ls. So root Ls divided by longer pendulum time period means longer pendulum length is nothing but a L. So root L minus root Ls. This is nothing but a both formulas. One it is in terms of the time period, one it is in terms of the length. These are the equation. When they are giving the two, one it is longer pendulum, one it is shorter pendulum. Number of oscillations how we can calculate means by using of this formula we can calculate it.